All right, Honor Stats, this is Chapter 6, Section 2, dealing with binomial probabilities. So the formula for a binomial distribution is n, let me get my marker on, is n CR, p to the power of r, q to the power of n minus r. So you need n, that's the total number of things happening. You need r, which is the desired number of things happening. P is your success and q is your failure. All right, so I have to give you n, I have to give you r, I have to give you p. And we'll see in a moment how you find q once you have p. First example I'm going to do today. On a TV game show, each contestant has a try at a Wheel of Fortune. The Wheel of Fortune is a roulette wheel that has 36 slots. One is gold. Well, if that ball lands on that gold spot, you win $50,000. From this statement, only one out of the 36 slots are good. That has gold on it, right? That is your success. You'll see in a moment, actually let me just jump to it. 1 minus p, 36 over 36, take away 1 over 36 is 35 over 36. Okay, so the p and q are going to be very easily. You'll see in my second example, the p is going to be a decimal, and you subtract it from 1. Again, found very easily. So right now, if that ball lands on that one of those 36 spots, which is gold, you're going to win $50,000. So our question at hand, what is the probability the game show will have to pay the fortune to 3 contestants out of 100? Well, guess what? N is 100. Remember, the total number of whatever's happening, in this case, contestants. And R, everybody, is our desired outcome. We want to know what happens if 3 people win. So we might as well stay right here, because a moment ago I gave you the formula. N, CR, P to the power of R, Q to the power of N minus R. And let's plug them in. N is 100. Combination is part of the formula. The R is 3. My success is 1 out of 36. That's our P. It's going to happen how many times? 3 times. They said there were 3 winners. Well, if there's 3 winners, then the percentage of people losing, which is 35 out of 36. If there are 3 winners out of 100, then 100 minus 3 is 90. There are 97 people that didn't win the gold or the $50,000. Now the tough part, you have to learn how to plug all of this into your calculator at one time. Then you're going to hit enter, and you're going to go to 3 decimal places. You see, I don't want the 100C3. I don't want that. I don't want the 1 over 36 cubed. I don't want you to round that one. I want you to do all at one time. So while I'm on video, 100, go to your math key, scroll over to probability, hit the number 3, and then hit the number 3. In my calculator I have 100 NCR3. Hit enter. It spits out 161,700. That's the answer for this thing. Leave it in your calculator. Hit times. Since 1 over 36 is in parentheses, type in open parenthesis, type in 1 divided by 36, close the parenthesis, and hit to the power of 3. If you don't use parentheses, it's going to give the power to the 36 and not the 1 over 36. Arrow, and then hit times, and now we do parenthesis, 35 divided by 36, close parenthesis, to the power of 97. Hit enter one time, and it spits out 0.2254, So 0.225. And you are done. You have now found the probability that if 100 people spin that wheel, 3 are going to win. Do it easier here, everybody. So I just want to explain what you need for a binomial experiment. There are a fixed number of trials, right? 100 was the one we just did. The n trials are independent, all right? So if I spin the wheel one time, it doesn't affect the spinning the wheel the second time. Each trial has only 2 outcomes, a success and a failure, all right? Success is denoted by P and failure is denoted by Q. That's the probability of each of those, okay? And then the central problem of the binomial is to find a probability of the R successes out of the n trials. And that's where we use the formula NCR, P to the R, Q to the n minus R. While we are here, we see the formula for Q is 1 minus P. Let's do one more of these where we have to find one thing. Privacy is a concern for many users of the internet. One survey showed that 59% of internet users are somewhat concerned about confidentiality of their email. Based on this information, what is the probability that for a random sample of 10 internet users, that's our N, that 6 are concerned about privacy, that's our R? So it's exactly 6. That's all they want to know. If I interview 10 people, are 6 going to say, I'm worried about my email? Well, here we go. The 59% is your success. That is your P, which we're going to write as 0.59. Remember, probabilities are numbers between 0 and 1. That means Q is 1 minus 0.59, which is 0.41. Putting those 4 pieces of information with our formula, it is going to be 10 C 6.59 to the power of 6, 0.41 to the power of 4. Again, 10, hit your math key, scroll over to probability, C6, hit enter, 210. While it's in your calculator, hit times, hit 0.59 to the power of 6, times 0.41 to the power of 4, hit enter, and I see 0.2503, so 250, and you are done. Okay. Now we're going to read this problem. We're going to use it for more advanced binomial probability problems. A biologist is studying a new hybrid tomato. It is known that the seeds of this hybrid tomato have a probability of 0.7 germinating. That's our P. Your Q is not germinating, which is 0.3. The biologist plants 6 seeds. That's our N. So I want to go to question B. Question B. Let me write each piece down for you. N, everybody, is 6. P is 0.7. Q is 0.3. B says this. What is the probability that at least 4 seeds will germinate? At least 4. So everyone in this class has to get down 2 main words, at least and at most. At least 4 means 4 or 5 or 6. Does everyone agree? What does at most mean? What if I said at most 3? 3, 2, 1, or 0. Don't forget 0, okay? So notice they've set that up for us here. We're not going to use any type of chart like the book says. We are going to do each one of these using our formula. So here we go. We're going to do the 4 right now. That is 6C4. The success is 0.7, and it's risen to the power of 4. The failure is 0.3, and there are 2 of those. Or means plus. Then we're going to do the 5 right now. Probability of 5 of these seeds germinate. That is 6C5. 0.7 to the power of 5. 0.3 to the power of 1. And now let's do the 6. Or put a plus sign. 6C6. 0.7 to the power of 6, 0.3 to the power of 0. Now, please do me a favor. If I drop these plus signs down, I want you to treat each of these 3 like 3 separate problems, rounding each 3 of them to 3 decimal places, and then add them. Don't plug this in your calculator all at once. In fact, somebody in my last class did, and they didn't get the same answer as we did. Okay, they were off by 1/1000th. So here I go. Let me do the first one, then I'll pause it and I'll do the other ones. So 6 math C4 is 15 times 0.7 to the power of 4 times 0.3 squared, enter. I get 0.324. Okay, I'm going to pause this and I'm going to get these other 2 answers right now. Okay, so plugging this into my calculator, I got 0.303. Plugging all of this into my calculator, I got 0.118. We add it together and get 0.745. Final answer. All right. That is at least 4 of these seeds germinate. Okay, what I'm about to do now is very important. I'm not going to write all of the 0.7s and 0.3s, but if I said, what is the probability of 0 germinating, you would do 6C0. Or, what if I said 1? You would do 6C1, or 6C2, or 6C3, or 6C4, or 6C5, or 6C6. That is the only thing that could happen in this example when there are 6 seeds. None can germinate, 1 can germinate, 2 can germinate, 3 can germinate, 4 can germinate, 5 can germinate, 6 can germinate. Let me go back to blue. Ladies and gentlemen, the problem we just got done doing was at least 4. Did I just circle at least 4? Yes. You got to know that. It's 4 plus 5 plus 6. Tell me what I'm circling now. At most 2. So if I said at most 2, you have to do 3 little problems and put them all together. Now, why am I doing this? Because you have to know at most, you have to know at least. The most important one, ladies and gentlemen, and before I do this, whatever number you get here, whatever you get here, whatever you get here, and here, and here, and here, and here, have to add and equal 1. They're the probabilities. Do you agree? I hope so. So, if I said find the probability of at least one seed germinate. Let me correct me if I'm wrong. At least one would be 1 or 2 or 3 or 4 or 5 or 6. So, if you want to, you can do those 5 separate problems. 6 separate problems. And get an answer for all 6 of them and add them together like the one we just did, at least 4. Or, if you know that every one of these added together equals 1, tell me what you could do with that guy right there. Good. You can do at least 1 minus none. 1 minus no seeds germinating. So if you simply do 1 minus 6C0, 0.7 to the 0, 0.3 to the 6, you will get what you need. Now, I do want to do this problem for you because of the weirdness of this answer. So I'm going to type in 1 minus, and then the rest of that stuff, and it spits out this, guys, 0.999271. Now, number one, it terminated. But the second thing, it helped me out because it didn't just give me 999. Guys, think about how many problems, if you rounded to 3 decimal places, would end at 0.999. A lot of them. Do that 271 for me because it kind of makes it its own problem. Does that make sense to y'all? You want to go a little bit further. Number 1, my calculator terminated. So if it terminated, might as well terminate where it tells you to, yes? So write what you see. A little bit different. This is just this type of problem. So if you get a really, really big answer or a really, really small answer, give me a little bit extra, okay? Now, if you put 999, there's a good chance I won't mark it wrong, but little food for thought, okay? So, in a sense, ladies and gentlemen, and I'm not going to give you crazy, crazy ones, but I will tell you this. I will give you a crazy one for this problem. Could you imagine if there were 23 seeds? You wouldn't have a piece of paper long enough to do that. 23C0, 23C1, 23C2, all the way up to 23C23. A lot, yes? But if I said 23 seeds germinate, what is the probability of at least 1? Now, if you want to do 1 and 2 and 3 and 4 and all those and add them all together, you're going to get the right answer. Or you do 1 minus 23C0. Okay? It's going to be on the test. It's going to be there. At least 1 is definitely going to be there. Okay? Now, I want you to look at what you see right now on this TV and use this, or keep in your heads for a second, because I'm now going to teach you 6.3, and everything I did right here is going to be 6.3. Okay? So that's the end of 6.2. We are done.